Welcome to this further maths video on log scales. You'll remember that last video we had a look at histograms. Log scales are useful when the histogram contains data that's very spread out. Here's an example that we can look at. So we've got mammals and their weights here. If we tried to plot this data, the weights of the mammals on a traditional scale in a histogram, we're going to end up with something like this. So because we've got the blue whale 136,000 kilograms and the Tassie Devil 7 kilograms, we've got a massive spread of data. So to ensure that we fit everything in, we've got to go up by 10,000 intervals. Okay. Now the issue with that is, how many animals have we got with a weight between 0 and 10,000 kilograms? Well, nearly all of them, 8 of the 9 animals, okay? But we've had to include this scale to go up to 136,000 to accommodate for the blue whale. So we've got all the animals here, and then big gap, and then the blue whale sitting on its own. So not that useful for, I guess, talking about the distribution of the data, this histogram here. Now, a way around it is to use log scales, okay? So what we would do for starters is we would take the log of each of the values up the top here, okay? So log of 4,800 is 3.68. Log of 1,100 is 3.04, and so on and so on. Now, if you're not sure how log works, refer to the next video in the series, which is what is a log, and you'll know a little bit about it. But just very quickly, what it means is 10 to the power of 3.68 equals 4,800. 10 to the power of 5.13 equals 136,000. 10 to the power of 0.85 equals 7. So that's just a very quick, gives you a little bit of an idea how the log scale works. But once we've got our log weights, we can go through and we can fill in a frequency table and draw a histogram. So in my frequency table up here, how many log weights are between 0 and 1? I can see that the Tassie Devil is, so I'm going to put a 1 up here. How many log weights are between 1 and 2? I've got 2. How many log weights are between 2 and 3? 1, 2, 3 of them. How many log weights are between 3 and 4? 1, 2 of them. How many between 4 and 5? Doesn't look like we've got any. And how many between 5 and 6? We've got the blue whale there, it's 5.13, so 1. Okay. Now that we've got our frequency table, we can try and draw this on our histogram down here. So between a log weight of 0 and 1, we had 1. So we can draw a bar here that goes to 1. Between 1 and 2, we had 2. Between 2 and 3, we had 3. Between 3 and 4, we had 2. We didn't have any between 4 and 5, but between 5 and 6, we had 1. Okay, and there's our histogram. We've been able to take a really spread out data set and bring the pieces of data much closer together, which enables us to draw a histogram much easier. So that's a quick rundown on how a log scale works. Most likely will come up in the further maths exam, either on exam 1 or 2, so it's really important that we understand how a log scale works and why we would use a log scale.